Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
So, we missed last week because I had my vaccine and it knocked me.
I also had my first vaccine, but I didn't get so knocked,
Yeah. Well, it's part of the mysteries of COVID.
Yep. Well, the nice thing is we'll be able to do like a developer conference or retreat or something sometime soon, hopefully. So that'll be nice.
I really enjoy working on things with no schedule or goals in person, just kind of hanging out with other programmers and enjoying, I guess I'd say bonding over our mutual fascination of this technology. That's what creates the connection between us, is the fascination with the technology.
It's really true.
Yeah.
Luckily, you and Bill and I have been able to do that quite a bit over the last few months, working on the Atomic Scala 3 book.
Mm-hmm.
It's been a lot of fun.
It has, and I feel like our last session was, I don't know, something really came together there, and I think part of it was Bill goes, let's just do something easy this week. Let's
After wrestling with type classes for a month.
Which we've made good progress, I think, on, but it's like bang against the wall, just trying to go, what's going on here, and how's this work, and how do we describe it? And then we just decided to go, let's just pluck this chapter from Atomic Kotlin and have a look at it. And you guys didn't even know it was possible to do this thing.
Yeah, that was interesting to discover a Scala feature that's been around for a really long time that I had no idea about. But I don't like it.
Well, and the syntax is really awkward, when you compare it to the way Kotlin does it. So what we're talking about is basically the properties. So
setter and getter
The
functions.
setter and getter and Scala, Kotlin has, nice clear syntax, so you know exactly what's going on. Whereas in Scala, it's like name of identifier _ equals, so it's like an overloading.
Yeah.
And it's awkward, but you probably, considering it's Scala, you probably want it to be awkward. It's not something you want to...
Yeah, and so this is used, if you want to use the equals to assign something, mm-hmm. then really what you're doing with the setter is calling a function mm-hmm. that has this weird syntax that allows you to use the identifier space equals syntax. But the only place I can see using this is when you have mutable values underneath the covers
in an object. Yeah.
And I haven't used mutable variables in so long.
You are so pure.
So pure. Feels so right.
Yes. Well, it's there to support the object functional hybrid system. So you can do it if you want to, but we're discouraged from it. So that's why you and Bill didn't even know about it.
Yeah.
And I only knew about it because we were just trying to cover all the features in the original Atomic Scala.
Somebody on Twitter, they're like, oh, another use of underscore that I didn't know about.
Yeah, I think, and I feel like there's been a lot of improvements in Scala 3 in terms of the, understanding that syntax matters. And it feels like with Scala, the original Scala, it was like not really a lot of thought given to the way syntax can
just throw it all in.
Yeah, pretty much. Yeah. And I feel like they've been working on improving it. The only thing that I guess I wish they would have changed case classes to data classes the way Kotlin has done it, because I don't know, case class doesn't really mean anything to me. I have to translate it in my head to being, it's a data class, it's a record, it's a, that kind of, or it's a data transfer object, or there's a bunch of things that they could have used.
Yeah.
But I've seen this happened in C++ when initially Bjarne said, we want to make this a small language. And so there was some overloading of keywords and things like that. And then pretty soon they started realizing, this doesn't actually make it easier, and it doesn't make it smaller.
Right.
It just seems smaller. And
yeah.
I think it's evolved nicely. I'm way more comfortable with Scala 3 than Scala 2.
Yeah.
Yeah.
We discovered, we were looking into ADTs, and we discovered with ADTs, that when you do an enum to create a sum type, then you do case and then the object type, and we were like, oh, are those case classes? And we tried it without the case, and you can do it, but it's not it's no longer like a class. But did we discover that if you do case and then the thing, that it actually is a case class? Like it has all the typical...
I think what it does is
methods.
the kind of, it does some fancy unpacking. I don't remember. It's been too long since we did the... It gives it extra powers.
Yeah.
When you say
so we weren't
case.
sure if they were the full extra powers of a case class. Anyways, and maybe another overloaded use of the word case.
Could be. So you wrote a article on, it was kind of, it seemed like the state of the union of Java, modern.
Yeah.
In fact, I think you used the term modern Java
Yeah.
in your blog post.
Yep. Yeah. And so this is a blog on jamesward.com that I just published this week. And yeah, it was called like the Modern Java Platform 2021 edition, because I'd kind of written a similar blog to this like 6 years ago. That one I had a much catchier title to. That one was called Java Doesn't Suck, You're Just Using It Wrong. Do you remember that one?
I remember the title.
Yeah. And the clickbaity title got a lot more traction, and this one, I've gotten old and boring, and so I just gave it a very straightforward title of the Modern Java Platform 2021 edition. But what I tried to do in the blog post was, for people that have not been in the Java ecosystem possibly for a long time, or maybe never, like, what is the state of the art? What's new? What's exciting? What should people do?
Because you were saying that those people were remembering Java from like EJB days.
Oh, so many people that I interact with at work or on Twitter, the Java that they're familiar with is the sad, what's the dark ages of Java. It really was the dark ages of Java with EJBs and all that stuff. And so that's what they think of as Java.
When Sun was really pushing EJBs are the way to go, and then we discovered billions of dollars were wasted.
I mean, what's funny is that a lot of the concepts from that era are coming back around.
Right.
That we see a lot of the things that were core parts of Java and the ecosystem are new again. They've just been like redone in new ways. Like, for example, the ability to make communication across the wire easy and transparent. Like gRPC, like, is kind of done that. And in a similar way to what we were doing with EJVs.
Specific. That's solving the general problem.
Yeah, and so what we've seen is like a lot of the stuff that was in the Java J2E, Java E ecosystem, the way that things were done, are being done again, but being done in platform agnostic, language agnostic ways. So serverless in some ways is kind of like what we were doing with WAR files back in those days. Now, today, most people don't use WAR files. They just have a jar file that they can run. They don't have a container that they put the thing into and all that. But in a lot of ways, serverless is like what we were doing back then.
And I think it's worth pointing out that we had, I think you were here for this, we had one of our early events up here. And I think it was when Martin Fowler was involved.
Yeah.
And so we had some folks, and it became clear that the whole EJB thing was pure ivory tower. It was totally untested thinking.
Yeah.
That Sun had said, "Oh, that looks good enough for us. Let's rush it in and let's start promoting it."
Yeah.
I think that's kind of the biggest problem that I've had with Java is its focus on, promoting what sounds good rather than actually engineering
Yeah.
and figuring out what works.
Yeah.
And so as a result, it's been way slower than the competing technologies have outstripped it.
Yeah.
Anyway, go on.
So in my blog post, I just tried to frame the world of like, what does the Java ecosystem look like today? And so a big part of it was around languages, because I think that that's where a lot of the exciting modern stuff lies. Like, yeah, Java is doing some interesting things. I, in the blog, quoted Brian Getter, didn't quote him, but referenced how he says, like, Java in some ways has the last mover advantage, where they intentionally move slowly, wait for things to kind of get worked out by some other languages, and then they add them in. We see that with the pattern matching stuff that's going into Java 16 that was just released this week, where they are getting a bit better pattern matching. It's not anywhere as good as Scala's pattern matching. It's getting closer to like Kotlin's pattern matching, but at least they're taking some steps to make the language better. So I focused mostly, of course, on Kotlin and Scala and the modern improvements there, just because that's what I have the most experience with. I haven't really written much Java in the last decade. It's been mostly Scala and Kotlin. Of course, I can write Java and do sometimes write Java, but if I'm going to pick a language, I'm going to pick Kotlin or Scala.
Yeah.
So there was some stuff about language innovation, and if you want to be modern, pick Kotlin or Scala. Hey, you could certainly stick with Java, and that's fine. Like, there's I did take a shot at Go in there. I called it archaic, which some people took offense to.
I don't see why.
With no one actually provided a cohesive, rational argument for why Go is not archaic. Which I think it's pretty intentionally archaic. And if that's what you want, if there are other things that you like about Go, then great, use Go. But don't try to call it a modern language.
In my mind, it's a replacement for C. It solves a bunch of problems that C has been stuck not being able to solve.
Yeah.
I mean, especially like easy concurrency.
Yeah.
C never mastered that as far as I could see.
Yeah.
And then, and a number of other things. It's an improvement over C.
Yeah.
And
if that works for you,
yeah,
great.
If what you're doing is basically C programming, then would want to use Go rather than C.
Yeah. Mm-hmm. So somebody who took issue with me calling it archaic, I responded and said, yeah, here's some of the top of my mind language features that I would consider modern that Go does not have. Mm-hmm. And listed, great pattern matching, ADTs, type classes, immutability by default.
But you don't really need those things, do you?
I can't go back. I do write some Go code. And when I do, I'm just like, why is it so hard to filter a list? Mm-hmm. Mm-hmm. Basic
and
stuff
how
like
do we know anything about the efficiency of doing that? Because Go's supposed to be fast, but you were having questions. It wasn't clear.
Yeah, it's not clear.
What wasn't clear? So it's.
So, anyways, I took my little shot at Go, but if people want to use it, great. I want to use Kotlin and Scala. Mm-hmm. And then also I talked about tooling. Build tooling, test containers, and IDEs as being kind of the core of my tooling. And I have my issues with every build tool. I certainly spend a lot of time in the great old pain cave. And we've talked about that extensively on this show.
But you didn't use that phrase, which is now embedded in my head.
Yeah. I've also spent my fair time in the SPT pain cave. Mm-hmm. I've spent a little bit of time in the Maven pain cave, but not too bad. And I think part of that is just that the ecosystem, somebody else has spent the time in the pain cave for me with Maven and built a plugin so that I don't have to go there. But the modern tooling is great. And I posted in the blog post a demo of how I actually use the build tools and the IDEs and test containers, how I use that all together to get like 1 second reloads so that I can test a change within 1 or 2 seconds, how I can easily bootstrap a new project, pull it into the IDE, get code completion, so I tried to show like what my modern tooling workflow looks like and I used in that case Spring Boot, Gradle, and test containers, but I do the same workflow even if I'm not using those tools. I always use IntelliJ, but VS Code certainly an option as well.
Yeah, I've had in the last week or 10 days or whatever some experiences with Gradle again in the Gradle Pancake.
Yeah.
And but I did this, like I'm coming up because I've relied on you and other people to create my Gradle build file so I could just...
You realize that was a mistake.
It's like,
rely on other people to do your build for you.
Yeah, I've slowly learned that, no, I have to understand all of the things. But I finally realized, a great way to start, and I don't know if you do this, is to go into IntelliJ and have IntelliJ create your bare bones Gradle build for you. Because there's some checkboxes you can put.
Oh, interesting.
And the thing is, and then it actually, you got no files in it, but it verifies that yes, the like the Kotlin
structure,
the Kotlin plugin can be found.
Yeah.
And the reason that I had to do this is because I started with just bare. I was looking at the things, and it says, "Here's what you put in for the plugin."
Yeah.
And I put it in. And I got all kinds of weird error messages. Now, this is before I started using IntelliJ.
Yeah.
And then I thought, I'm flailing about trying to figure out how to get started with this because I couldn't get any. I couldn't find anything on the internet. I'm going, I must be doing something wrong. I don't understand it. And then I did it with IntelliJ, and it built the bare bones Gradle build file, and it worked, even though it was importing the Kotlin thing.
Yeah.
And then I tried updating it. I discovered, IntelliJ uses 6.7, and I tried updating it to 6.8, and any version, and 6.8 has been out like 5 months or something, and they've had 3 different subversions, which is maybe a little questionable. And it's like any version of 6.8 that I went to, it couldn't find the
I wonder
Kotlin
if this
plugin.
is so the Java world, in a lot of ways, the Kotlin related part of this has been had some issues lately because of Bintray. Bintray has had some outages, and they are shutting down Bintray in May. Mm-hmm. And so there's been a lot of people scrambling to move off of Bintray to Maven Central, and Maven Central has been such a critical part of the whole Java ecosystem and has been mostly reliable. There's definitely some issues with deploying new artifacts, but most of the time consumption just works. I've become incredibly thankful for Maven Central and just
as Bintray is shutting down.
Yeah, and just what a core part of the Java ecosystem it's been. And but so your issues may have been related actually to JSON or
this is only
Bintray.
Using Maven Central.
Yeah.
There was no Bintray at all. But when I was able to go, IntelliJ makes this work for me.
Yeah.
It's like, okay, I'm more of a fan of IntelliJ now.
So
than I was before.
They're still using, as far as I know, the groovy Gradle syntax, and I've tried to on all of my projects over the last year use the Kotlin syntax.
There's an option.
Is there?
Check
so you
and
can
they'll generate which I haven't done yet because I'm trying not to change too many things at once.
Yeah. So usually I don't use that way, or I've never used that way to bootstrap a Gradle project. I get very particular about my build files and how they're structured, and just things like, in the Gradle build file, when you specify a dependency on a Kotlin standard library, either, there's a bunch of Kotlin standard libraries, like there's the standard one, then there's the reflection one, then there's a few others. Anyways, the Gradle has a syntax where you just say implementation and then Kotlin and then Kotlin dash standard, whatever the dependency is there. So it's this really nice, concise syntax, but a lot of the build files that I see don't use that nice syntax to pull in those Kotlin standard dependencies. So anyways, I'm very particular about my build files and how they're structured, and so I don't let anyone else do that. So usually what that means is I go find one of my previous build files and go copy and paste it when I start a new project. But
yeah, it's one of those, there's more than one way to do the same thing. So
yeah, there's a lot of ways. Well, and plugins are one of the abysmal parts of Gradle, where it's just like, God, why do we have so many different ways to pull in plugins? And then it depends, like, is the plugin on the Gradle plugin portal or is it on Maven Central? And if it's on Maven Central, then you had to like put some special magic syntax in your settings.gradle file, and it just...
And my problem is when there's multiple ways to do the same thing, I look at somebody, a file that's done it differently, and I go, oh, that's different. I wonder why.
Yeah.
And I have to figure out, and then if I come back down and it's like, well, it's not. It's just the same. It's just different syntax for doing the same thing. Then I'm going, I just wasted a whole bunch of time figuring that out.
Right.
And I don't know when the next thing is going to be different or the same. Or
So if you stay on the happy path, then which the happy path is fairly well paved in some places. So if you go to start.spring.io and you go generate a Spring project and you select Gradle for the build tool, what it gives you is pretty good. Not perfect, and I have to go make changes. But
and this is Spring Boot?
Spring Boot, yeah.
Okay.
Yeah. Same is true for Quarkus and for Micronaut. They all have websites that'll give you a starter project.
Even if I'm not using Spring.
No, they're really intended for. I mean, you could.
But I could do that and take that stuff out.
You could, yeah.
Okay.
But if you're going to start with any of the three of those, the starters that they give you are pretty good. Give you a pretty good build definition, and so I think if you stay on that happy path, like I'm building a Spring Boot application and I'm going to go to start.spring.io and generate, like what you get out of that is pretty good. Mm-hmm. So I talked about build stuff, and there are issues, but I'm pretty happy with the state of the developer tooling side of the Java ecosystem, and so that was part of the blog post. I feel very productive with it. I definitely have things that I do that are probably different from the norm that I think make me productive, like using test containers to spin up my service dependencies and stuff. But generally, I'm happy with it, and I think that it continues to improve. Then I also talked about frameworks in the Java ecosystem. I specifically highlighted Spring Boot just because it is the standard. If you want to be in the OO annotation based world, like Spring Boot is just great. It works. It's a huge ecosystem, lots of things. Alternatives to that would be Micronaut or Quarkus. There's of course many different alternatives, but I think those are the two that stand out for me. All of them work great with Kotlin. The one caveat that I said in there was that if you want to do Kotlin coroutines, Spring Boot or Micronaut are better. Quarkus doesn't yet have coroutine support, which is unfortunate. I think they're working on it, but and then in the Scala world, I said like Play Framework. I've used Play Framework a lot, and
used to be a big proponent of it.
Yeah, and I do like it, but as I've gotten more functional programming oriented and tried to do things more pure functional, Play Framework has become less of something that I want. I think it's still a great framework and the productivity is great, but it definitely uses the typical kind of dependency injection style of things and not the pure functional style of things.
So what do you prefer?
So Zio is where where all my interests are right now. Unfortunately, Zio does not yet have like a full-blown web framework that would be a good alternative to Play Framework. They just announced a HTTP server that provides a lot of the foundational pieces to that, but they don't have like the full-blown web framework yet. And so Zio for a lot of things I think is a great option today, but if you want a web application where you build the front end and the back end in the same code base, then I don't think Zio is quite there yet. So I talked about Zios, but I said like the frameworks in the Java ecosystem, there's a lot of great options there, whether you're doing Scala or Kotlin or Java.
And they're mature.
They're mature, yes. Yeah. Yeah. I mean, Zio, I wouldn't say is super mature yet, but is getting there. Whereas Spring Boot, very mature.
Mm-hmm. And Micronaut too.
Micronaut is pretty new, but it builds on a lot of the foundations of other things. So
and the technology is pretty amazing. I mean, this idea of doing dependency injection at compile time is quite interesting.
Yeah, and which works a lot better with GraalVM, which I also talked about in the blog post, was around, all right, we do have a way to create native executables so that they start up faster and don't have the garbage collection overhead and some of those things, and so if that's something that you need, then Micronaut may be a better option than Spring Boot. Spring Boot does have a way to use GraalVM, and I've tried it and had limited success with it just because it's early days for a lot of that native compilation, GraalVM native image stuff, and so Zio on the other hand is actually a lot better with that. Really a lot of things in the Scala ecosystem are a lot better with that, because if you are purely functional, that code can be much more easily ahead of time compiled. Whereas in the typical Java reflection oriented stuff, it can't ahead of time compile dynamic reflection based stuff. And so then you have to tell GraalVM about it, and that can be challenging. And I've run into all sorts of insurmountable hurdles with that, but the tooling around that is evolving, and there's something called Spring Boot native or Spring native. Micronaut has built-in support. Quarkus has great support, but there are challenges. It's not a easy path.
I guess that would be an example of the invariance making things faster that you were talking about earlier.
Yeah, describe that to me.
Well, just because there isn't this dynamic nature.
Yeah.
It can produce a much faster.
It can optimize it.
Yeah.
It's weird to me in the Java ecosystem that we've let so much dynamic stuff creep into our world in there. So dependency injection is a huge one. A lot of it is basically just dynamic programming, like dynamic runtime wiring. Serialization is another big one. Jackson is the primary JSON library in the Java ecosystem, and a lot of I think they have some other ways to use it, but essentially most of the ways that people use Jackson in the Java world is based on runtime reflection. And then a big one which just hurts me is that most of the server-side templating in the Java ecosystem is actually dynamic runtime stuff. When I started using Play Framework was the first time I started using compile time server templating, and I can't go back. Like the fact that people allow runtime bugs to creep into their code, into their programs, because they essentially just are running a template at runtime and not having compile time validation, just is mind-boggling.
Well, it's not just the validation; it's the speed.
Performance could also
and you're doing something you're doing something over and over again that only really needs to be done once.
Yeah. So I think there is caching and whatever, but yeah, I think the challenge is that you definitely pay a price on you do have a compile phase and for your server-side templates, and so that can be a bit of a or can seem like a developer productivity hit, but the validation that you get is so worth it. JSPs were actually probably the first place where I did this, because the first way that people use JSPs were that the first time a request would come into a JSP, Java Server page, the server would actually compile that JSP page. So it was still basically runtime, but there was a compilation process. And then what happened was people took those JSP compilers and actually built like Maven and AMP plugins for them so that you could pre-compile your JSPs. So that, because what would happen is the first time you started your server and somebody would request a JSP, then they would sit there and wait for the JSP to be compiled. And obviously that's silly, making your user sit there and wait for your JSP to compile. So they started doing pre-compilation of JSPs, which was a good progress, because at least that helped us get validation that our templates were valid syntax. Anyways, it just is wild how much dynamic runtime stuff we typically do in the Java ecosystem, which I'm glad to see. I'm seeing a lot of that stuff diminish. GraalVM is part of the motivation for that, but
it seems like there's always a line that you cross. I mean, because at some point the software needs to be interactive and dynamic, but where that line is, I think if you're doing it in a sloppy way, you go, we'll just let the computer, it'll be like PHP. Computer will just calculate everything every time a server comes in. A user comes in and hits a page. Versus, maybe that's not. That for many reasons, not just speed. I think when you point out the kinds of tooling that can help you find problems, that's when it becomes really compelling for me. How does it help the programmer? But at the same time, you get better speed. So we had a comment from somebody that sort of fits with.
So somebody had said, what about Java 16? It seems like they're getting some of these language features in Java 16 with record types and a bit better pattern matching. And I think there was a question like, are Java developers going to actually ever get and use these features, or are most people just going to use Kotlin or Scala?
Java 8 is still being incorporated into the world.
I mean, most of the production Java apps are running on Java 8 still,
and not necessarily using many of the new features that were incorporated into Java 8.
It's true. Like if you look around at Java 8 code, whether on Stack Overflow or on GitHub or whatever, you don't see even like a lot of stream usage. You still see a lot of like mutable for loops and stuff.
Sure. Because that's what they were doing before, and that worked. And it's a significant mental shift to go to something like streams. So you add some of these other features that have been included in more recent versions, or maybe included. That's the other thing is, and I've been struggling with this. We have the same level of change in, number change. It was like, so Java 16 is out. Well, except that how many of those features are experimental? I don't know. If I was a company, I would say, we're not going to mess with that. We're just going to wait for the next long-term support version. And it's how many people are using Java 8 simply because it's the current long-term support version. Whereas what they're really doing is programming in Java 5.
Right.
And I don't know, it's all kind of, and as we've discussed before, if you really want the new and interesting features, and I think this user was saying, they were the person who was commenting was saying, well, some of these features are kind of like partial.
Yeah.
And so if I really want, I don't know, pattern matching,
matching's a good one.
If that's an important feature for me, wouldn't I want the more sophisticated one rather than the partial feature that that's been incorporated here, which I can't really use until the Java 17 comes out and we know what's actually going to be in it. Because right now, this is the confusing thing for me, is because when you look at the versions that are coming out, they'll say, okay, well, this is our first, I don't know what term that they use, first test version of this feature. And I don't even know if that feature is going to make it into the long-term support version. Right. So,
does the compiler give you some warning, or do you have to like specify a compiler parameter to turn on these features, or I don't know how all that works.
I don't know. I haven't been, I'm not going to write to the intermediate versions. Yeah. I wish they would say, look, this is an intermediate version. This isn't, some of these, and they do sort of, but some of these features may be in the language and some of them may not. Yeah. These are test features. And so I'm not going to put the effort into figuring them out until they're actually
finalized.
In the language. And I just have trouble with this idea that, Java 16, it's got the same number bump as Java 17. But Java 17 is very different than all of the 6-month releases that come before. It just makes me, I don't know, something about it makes me uncomfortable.
I don't know if I have much of an opinion on that, just because I don't do Java much anymore, Java language stuff. It's a hard problem. Like in the Scala ecosystem, you have to opt into language features that are experimental, and you in some cases can do that through an import. In some cases you can do that with a compiler setting, some cases either. And so it's got to be hard as a language designer, because you want to experiment with things, but how do you convey that? How do you let people know what they're getting into? But how do you actually have a release that people will try it? Because I think that's one of the challenges, is that you need a bunch of people to actually like really use a feature so that you can understand what changes need to be made to it.
But this feels like somebody's trying to trick me into using this and testing their features, and I may accidentally incorporate one of those features in, and then later they say, that one didn't work out. Thanks for testing it for us.
Yeah.
I don't know. It makes me, I don't know. Uncomfortable, but
one alternative is that you somehow have a much more thorough design by committee process, and I don't really like that approach. In some ways, like, isn't the Python improvement process stuff like kind of like a design by committee on a feature, and then they have some way in Python to like add it in as experimental or something, and then
they do. They incorporate them as experimental features, but they're very clear. That we're trying this feature out. This is an enhancement. Python, it's a PEP, Python enhancement proposal.
Okay. PEP.
And we're working this out, and we want to see if it works, if it needs to be improved. So there's a lot of open discussion about it. And I guess sometimes it gets a little heated, and I know that Guido got tired of being in the middle of all that, and power to him that he.
It's such a hard thing.
And
want things to move forward, and but you got to get feedback, and then people have strong opinions about it, and it's hard to be a language designer.
Oh, very hard.
I'm glad that's not my job.
No. Every once in a while, I've imagined, what it would be like to design the perfect language, and I just go, I have a hard enough time understanding the existing languages, and that's something we were talking about a at Coffee was, I think there's just not enough focus when you're trying to explain features and perhaps motivate features into a language, is what problem are we solving?
Yeah.
And it's very much like the how do you describe a monad?
Yeah.
Well, it's a burrito. Or the other night, since you have small children and Bill's about to have a small child, I thought, no, it's actually like a diaper.
That's right. Monads, they're like diapers.
Yeah, full diapers.
Yeah.
Yeah. Well, in any event, it's like, well, it doesn't really matter. The implementation is not, and that's what people focus on, is that particular strategy
Right.
to solve the problem, and not the problem that they're trying to solve.
Yep.
They decide, well, that's obvious. I don't know. I'm not sure. Or it becomes so obvious to them that they stop thinking about it. And when you're trying to explain it to somebody, if you don't start with what problem are we trying to solve,
Yeah.
then it just sounds like, I use the example of describing hash functions. And if I just jump in and say, so, we have this list of things that we keep fixed size, and then you can jump into it, and then you have this chain. Suddenly it's overwhelming. Why are you doing all this?
Yeah.
But if you have to start with, we're trying to make the fastest lookup possible.
Yeah. Yeah.
And then it all falls into place.
Yeah.
And I think that's key. Well, like when we're describing, we're trying to figure out type classes.
Mm-hmm.
And I struggled, and then finally I started going, oh, this is another form of, we want to write, well, let's just say a function. We want to write a function, and we want to use it for more than just one type.
Yeah.
And there's a number of different approaches to that problem, and they all have their strengths and limitations.
Yeah.
And type classes is another way to do that.
Yeah.
It's like, oh, okay, now it's starting to fit for me.
Yeah.
Whereas before it was just, oh, you do this thing and it reaches out and it grabs this thing, and it's like, why are we doing that?
Yeah.
What is the point? And how am I supposed to explain this to somebody if I don't start with, hey, we have a problem.
Yeah.
And here's how we're trying to solve it.
Yeah. Yeah, and I think we talked a while back about how Elm went through that process of Evan, the language designer, said, what problem are type classes trying to solve? And people tried to explain to him what problem it was trying to solve, but when I'd checked in on the thread, no one was able to successfully describe what problem type classes are trying to solve.
I think we're going to do it in Atomic Scala 3.
Yes, we are.
Because we have to.
Yeah.
But I think we're getting closer too.
What's interesting is that a lot of times when we can't describe the problem, or it's very hard to do that, we resort to either analogies like the burrito for monads, or we resort to specific implementations. So in the case of type classes, we say, okay, think about a JSON serializer. So we go back to
that did not help me.
Yeah. Yeah, so it's...
Because I could, solve that problem in a number of different ways, which is actually really important to look at.
Yeah.
Yes, there are more than one way to solve this problem, but what is the problem?
Yeah. Yeah. Or we resort to the mathematical definition, the category theory definition of the thing. Like for monad, what is it?
Monad is a monoid in the category of endofunctors.
Yeah.
Why can I remember that? I have no idea what it means.
That was good.
I'm just making noises with my mouth.
Yeah. And that may be the actual true category theory definition of a monad, but it certainly doesn't help anybody understand why you should use monads.
Right.
What problem they solve.
Right.
Yeah.
It's been a long path. I feel like I'm getting it. I could be wrong.
Yeah.
Had this experience before, but it was like when I was figuring out what dynamic binding did at first, using the C++ Cfront compiler.
Yeah.
And I had to look at the generated code and say, wait a minute, it's looking something up in a table. Why the heck is it doing that? And it took a lot. Once I understood what it was doing, it took a lot longer to understand why.
Yeah.
Because there wasn't that motivation.
Yeah, yeah.
It was just, oh, well, we need dynamic binding.
Yeah.
Okay, well,
Yeah.
why?
There's something in here around philosophy and like Plato's cave and all that kind of stuff. Really about how we see reality and the difference between form and what is it in Plato's world? You can have the form of the thing and then the object of the thing, or something like that.
Well, he had an idea that there was this actual ultimate truth, and then there was some light being shined through that, and it made these images on the wall.
Yeah.
Very much like our screens.
Yeah.
And then, so you were seeing the images, and you were interpreting that as reality.
Yeah.
And actually, there was some, I forget how he described it, but there was some pure concept that was there, that was generating these things, and it was getting distorted by the projection.
Yeah. So in the case of monads, it took me a long time, years, to understand kind of what monads were, but I used them a lot. And so if I were asked at that time to describe monads, I would really just be describing the projection on the wall, my experience of them, but not describing the actual reality that was behind that. And I think in some ways what we're describing is that to be able to understand the why is to recognize the actual reality, or like you've moved past the projection to something deeper. And for me, maybe for a lot of people, it's very hard to go take our experience beyond that projection and our perception of our experience to the deeper, more real concepts.
Yeah, and just, I don't know how my brain works. I'm stuck because I want to know if you're going to design with something, you have to understand what design problem you're solving. And so I kind of have to go from there, and it's just, I guess, because I've done it this way for so long.
Yeah.
I got to know why does this feature exist? What is it doing for me?
Yeah. Yeah. Yes and no. I think, like, without me understanding monads, but having used them, I can then like basically pattern match and be like, okay, this would be another great place for monads without really understanding them. But I think that then my pattern matching is limited on the places where I could see where monads would apply. Whereas you take somebody like John DeGoes, who, and many other people, but who really understand monads, and then can be like, oh, there's this universe of places where we can use monads because they understand the deeper part of it, the deeper reality of it.
Well, and I have to say, I really admire your ability to wade in and just go, oh, here's the thing. Let's try and build something with it. You know, and I'm going, whoa. Hang on. I need to understand why we're doing this before you just go in and start thrashing around. Yeah. And yet you can learn a huge amount by actually going in and saying, oh, we plug the pieces together and it works. and you kind of leap forward that way.
Yeah.
And I think that is super cool that you can do
different
that.
Paths to understanding.
It's definitely different paths, yeah.
The object, not the
But I get bound up with, I can't just be sticking capacitors on this circuit without, why am I doing that? What if I put the wrong capacitor there? What happens? Yeah. I don't know.
Yeah.
My first experience in electronics was they handed us some LEDs, which were like $1 a piece at the time.
Yeah.
And I think I go, oh, this will light up if I put current through it. And if you put current through it, it has no resistance.
Yeah.
And so it's just like goes to the maximum amount of current and the thing pops and sends the end, little thing across the room.
Yeah.
I'm going, oh, I didn't, I broke it because I didn't understand what was going on.
Yeah. Yeah.
And so I think that's made me careful ever since, gun shy probably.
Yeah.
And not
better understand this thing or else it's going to blow up.
It's going to blow up, right?
Yep.
Yeah.
Yeah. Huh. That's interesting. So Java 16, I don't know. I mean, I'm sure people will use it. I'm sure people will like it. I'm sure there's great improvements there. I'm probably not going to use it.
I'm not gonna write about anything until Java 17 comes along, and then I go, well, that's a real thing.
Yeah.
Java 16, is it real? I don't know.
I mean, I guess you're in an interesting position in that you actually do write about these new features for your thinking in Java updates and stuff, and so you actually do need to understand record types, whereas record types are going to probably be used by Scala and Kotlin in some way, and I won't use them directly. So I'm glad that somebody's going to understand them and use them. But
why wouldn't you use them?
I'll use data classes and case classes, and maybe underneath the covers, they'll turn into records or something. I don't know how that's going to work, but I'm going to let the Scala and Kotlin language designers think about what records mean for Kotlin and Scala, but you, for your writing, you will need to understand these features,
deeper understanding of them. Yeah,
write about them.
Yeah, and I think it'll also change serialization for Java.
Yeah,
because mostly that's what you're sending back and forth on the wire is records, and the general serialization that they put in was just a complete cluster.
Yeah.
It was just yet another Java feature that was tossed into the mix without really thinking about what the impact was, and has caused apparently all kinds of security issues, and
it's amazing that serialization still is so hard. It still is something that we all wrestle with in so many different ways,
because you really want it to be automatic and secure, and
efficient, and I certainly appreciate schemas, so I can validate things and evolvable, and it turns out it's a really hard problem that 40 years in we're still trying to figure out how to take data out of memory and put it into a form that we can send it to somewhere else.
To take this object and put it over there. Why is that so
That so
hard? Well, and why isn't it a solved problem? Why?
Yeah.
And I think it's just because on the list of things that needed to be solved, it's like, let's just do a quick and dirty serialization thing, and then later we'll revisit it.
Yeah.
And it's 25 years later, and now they're finally looking at it. And
well, it turns out it's actually the surface area of that one problem seems simple, but as you really get into it, it is not. There is so many facets to this that are so many pieces to the problem that it turns out it's actually a really complicated problem. If it was simple, I think it would have been solved already, but it's not simple.
Right.
Because you've got to think about performance, you've got to think about size, you've got to think about interoperability, you've got to think about you have to think about, let's see, what are some other aspects to serialization? Forwards compatibility, backwards compatibility. You have to think about, like, one of the nice things about JSON was that it was easily human readable, that you could, see it. Whereas binary formats can be much more efficient, but then you need some tool to look at it.
Well, somebody has to think about those, and I feel like that's the, compiler, designer, engineer. That's that's part of their job.
Yeah.
That has been kicked down the road for 25 years.
Yeah.
And, you know, I, as a end programmer, putting that burden on me is not a reasonable thing. I mean, it's very much like, oh, let's just throw in low-level concurrency. And then the programmer will have to, you know, they'll figure it out. You know? And it's like, no, it's not. There are just so many factors there that are too complicated.
I think one of the biggest is the how you map the data, the serialized format, to types in the thing. Like, that turns out to be a really hard problem. I just saw some JSON recently that put the type information into the JSON, which is a little bit awkward because JSON already has essentially a type system. It's a very limited type system. But so they, in JSON properties, would say the type of this thing is a string, like actually in the data. And I have issues with that. But then you still have to figure out, all right, the JSON says this thing is a foo. I need a foo in my programming language to map that thing to. What if I don't have a foo type? Then what do I do?
Well, and you know, I think this brings up the issue that we don't even understand the shape of the problem, because it may be that to solve the problem, you do have to include type information in your package that you're shipping. There, you know, that's kind of a PhD dissertation sort of thing.
Yeah.
You know, that you need to prove one way or the other. Yes, you have to have it, or no, you don't. And the fact that we haven't even figured that out to the point where we can say yes or no.
Yeah, I mean, protobufs have, and I'm sure many other technologies, but this idea that, you have a representation of the type system, and then you generate the actual types in your programming language, and you also generate the mappers that know how to take the serialized form and turn it into those types from that shared, what do you call it, IDL? You're the one who introduced me to that.
Interface Description Language.
There's definitely something useful and innovative there, but there's all sorts of trade-offs to that, because then you have to generate code, and generating code has all sorts of drawbacks.
There's a lot of, I think, fundamental theory in here that we just haven't given enough energy to, because we're busy solving so many of these other problems. But I wonder, this could be one of those things that justifies a new language at some point in the future.
I mean, Unison. We always talk about Unison, but Unison, I think, is making some interesting strides in this direction. But there are others as well. So I know that Heather, who worked on Scala at EPFL and Scala Center, she's now doing a doctoral program on distributed systems and looking at some of these problems. But we'll have to have her on the show sometime. But
wow.
Yeah, I mean, I think there is a lot of research going into this, but it's going to take a while for that research to be something that we all can use. But hopefully in a decade, we'll be like, oh, thank God somebody solved the serialization problem.
Yeah, and I think to solve the serialization problem, they'll probably end up solving a bunch of other problems as well.
Yeah. Yes.
Yeah. Suddenly, that'll be a leap forward in our just understanding of computing. But as things become more and more distributed,
we have to.
All of that stuff is becoming more important. We can no longer imagine that we're just running on our little isolated machine.
Yeah. Yeah. It's nice and simple, but doesn't match well with reality. Yeah. So Java 16, I look forward to learning about it from you. Back real quick to my blog post, there was a couple other topics that I covered in there. One was reactive, and talked about kind of different fundamental ways to look at reactive, and coroutines as part of that, and stream processing stuff, and I think that's the reactive stuff is a place where the Java ecosystem really shines and is doing a great job.
This has got to be for a different podcast, but I'd like to delve. I've kind of just ignored the whole reactive world, and I'd like to delve into that.
Next episode, that'll be a fun one.
Yeah. Just kind of pick your brain and say what's going on here and why. What problem are we solving?
What problem are we trying to solve?
Yeah. Exactly.
I'll give that to you, but we'll move that to the next episode.
Right.
The problem that reactive is solving is that things sometimes sometimes your programs are just waiting for something to happen. And it turns out that our programming models are really, our legacy programming models at this point are really inefficient at handling those waiting states. So really it's just an efficiency is the problem that we're trying to solve, is we're trying to make programs that wait more efficient.
Just sounds like async. Why has it got a special name?
It's just async.
Oh, okay. Oh.
There are some other pieces to it,
okay.
Along with async. So, so we'll talk about that one on a future episode. But check out my blog, jamesward.com.
Okay.
Is where it is, and hopefully people get something out of it. But anything else?
No, I think we're good.
Awesome.
So see you next week.
See you next week.